Pretty much every modern app you use, from your banking app to your favorite game, it all runs on data. And that data lives in databases. But here's the problem, a big one. Your Java application and your database, they don't speak the same language. They're total strangers. So how in the world do you build a bridge so they can actually talk to each other?
Yeah, and this visual really gets to the heart of the issue, doesn't it? Over on one side, you've got your Java app filled with all your brilliant code and logic. And on the other side, you have the database, in this case an Oracle one, guarding all that crucial information. They are just totally separate. There's this huge gap between them. They desperately need some kind of translator to make any kind of communication happen.
And that's where our hero of the day comes in, JDBC. It stands for Java Database Connectivity. Honestly, just think of it as the universal translator, the essential bridge that connects these two worlds. It's a standard Java API, which is just a fancy way of saying it's a set of rules and tools that gives your program a single, consistent way to talk to pretty much any relational database out there. I mean, MySQL, Oracle, SQL Server, you name it, JDBC can handle it.
Okay, I love this analogy because it makes everything so clear. Imagine you're at a restaurant. Your Java program, that's you, the customer, ready to order. The database, that's the kitchen where all the magic happens and the food or data is prepared. Now, you wouldn't just barge into the kitchen and start shouting your order, right? Of course not. You talk to the waiter. And in our story, JDBC is that waiter. It takes your request, brings it to the kitchen, and then delivers the results right back to your table. It's simple, elegant, and it just works. All right, so we know JDBC is our waiter, but how does it actually work? What's the system behind the scenes? Let's peel back the layers and take a look at the actual architecture, the blueprint for making this connection happen. Well, the whole system really boils down to just a handful of core components. First, you've got your Java application, then there's the JDBC API itself. Next, a really important player called the driver manager. After that, you have a specific JDBC driver for whatever database you're using, and finally, of course, the database itself. Let's see how this team works together. And boom, this diagram shows the entire flow perfectly. Your Java app at the top talks to the standard JDBC API. Those calls then hit the JDBC driver manager, which acts like a traffic controller. It looks at the connection info you gave it and says, aha, you want to talk to Oracle, and it directs your request to the specific Oracle driver. That driver is the real translator. It turns your Java requests into a language the database can actually understand. The genius of this setup is something called database independence. You could swap out that Oracle database for, say, MySQL tomorrow. And guess what? You only have to change the driver. Your main application code, it doesn't have to change at all. That's huge. Okay, that's the what. We know the components. But what about the how? How do you, the developer, actually write the code to make this happen? Well, it all comes down to a really clear 5-step process. Let's walk through your how-to guide for getting connected. And here it is, the roadmap. These are the 5 key steps, all laid out. It's a super logical path from start to finish. And trust me, once you do this a few times, it just becomes second nature. It's the bread and butter for any Java dev who works with data. All right, let's break this down. Step 1, you load and register the driver. This is basically you telling Java, hey, listen up, we're going to be talking to a MySQL database, so get that translator ready. Step 2, you get the connection. This is where you use that driver manager to open up a live link to the database. Step 3, create a statement. Think of this as opening a channel to send your SQL commands through. Step 4, you execute the query. You send your SQL and wait for a response. And then, step 5, and please, do not forget this one. You close the connection. This is so important. It releases all the database resources and keeps your application running smoothly and efficiently. Okay, so you've sent the query. The order is in with the kitchen. What do you actually get back? What does the waiter bring to your table? What you get back is this really cool object called a ResultSet. And this diagram shows it perfectly. It's not just a big jumble of data, it's structured, like a table sitting in your computer's memory. But the key thing to see here is that little pointer or cursor. See how it starts before the first row? That's intentional. You use a simple command, like next, to move it down one row at a time. This lets you go through all your data row by row, nice and clean. Okay, we've got the fundamentals down. Now let's talk about making smart decisions. As a developer, you have some choices to make when you're writing your code. And trust me, these choices can have a huge impact on your app's performance and, really importantly, its security. So one of the first big choices you'll face is whether to use a statement or a prepared statement. Now, a regular statement is okay for really simple, static, one-time queries. But just look at the prepared statement column. It's built for dynamic queries with parameters. It's way more efficient because the database can pre-compile it. But the most important reason, the absolute deal breaker, is security. A prepared statement protects you from something called SQL injection. That's a nasty type of attack where hackers can sneak malicious code into your queries. So let me be clear. For any real-world application, prepared statement is the way to go. It's just the professional choice.
Of course. Just like any technology, JDBC hasn't just stood still. The drivers themselves, those critical translator pieces, have actually evolved quite a bit over the years. They've gotten a lot more efficient, more portable, and just plain easier to work with. And this slide tells that whole story. Way back, we started with a Type 1 driver, which was kind of clunky because it needed this other thing called an ODBC bridge to work. Then we got Type 2, which was faster because it used native code, but that meant it was tied to a specific operating system, not very Java-like. Type 3 was a step up, using a middleware server, but it added complexity. You can see where this is all headed, right? It's all leading to that final sleek version on the far right. Yep, it all leads us here, to the Type 4 driver. People often call it the thin driver, and this is the gold standard today. Why? Well, for one, it's 100% pure Java. It talks directly to the database over the network. That means you don't need any extra software installed on the client machine. It'll run on any platform that has Java, and it gives you the best performance, hands down. So when you're starting a new project today, a Type 4 driver is what you're going to use, period. So we've been deep in the technical weeds, which is great, but let's zoom out for a second. Why does any of this really matter? It matters because JDBC is, without a doubt, the foundational technology that powers pretty much every single data-driven Java application on the planet. It all comes down to this number, 1. JDBC provides that one single, standard API that gives any Java application the power to connect to the entire universe of relational databases. It really is the universal key that unlocks all of that data for your code. So, if you're going to take away just a few key things from all this, let it be these 4. First, JDBC is that essential bridge between Java and your database. Second, connecting to a database always follows those 5 core steps. Third, for security and performance, you should always be using prepared statement. And finally, for any modern project, a Type 4 thin driver is the one you want. That's the playbook. So we've walked through the blueprint, the components, the whole process. You now know how to build the bridge between your code and your data. So the only real question left is, now that you have that power, what are you going to build?